Welcome to the third video of this series on how to perform supervised classification using ERDAS IMAGINE. In this video we will cover the steps involved in processing the supervised classification. At this stage, the analyst has captured training samples and evaluated their representations of the desired classes. They are now ready to classify the rest of the image based on these signatures. Let's begin. First, load the image to be classified into a viewer. From the Roster tab, under the Classification group, expand the Supervised Classification menu and select Supervised Classification. This opens the Supervised Classification dialog. In the Supervised Classification dialog, set the input raster file to the image you want to classify. Set the input signature to the signature file we created and evaluated in Video 1 and Video 2 respectively. In the classified file, type in the name of the output file. Use a name that will assist you in identifying the file, for example, capetown_superclass.img. We will also create the distance image file to be used to threshold the classified image file. Click the output distance file checkbox to activate it. Under file name, enter the name for the distance image file, for example, capetown_distance.img. Because we are using the maximum likelihood method for the classification, the pixel values in the distance raster is the Mahalanobis distance between the corresponding pixels in the input continuous raster layer and the signature to which it was classified. In the Supervised Classification dialog, under the output file name, click Attribute Options button. Analysts can specify the statistical information they want to append to the output classified layer. The statistics are based on the data file values for each layer for the signatures. We will select the minimum, maximum, mean, and standard deviation statistical parameters. We will also check on the layer checkbox to make sure that the statistical information is presented in the raster attribute cell array by layer, for example, the minimum, maximum, and mean values for band 1, and so forth. Close the Attribute Options dialog. In the Supervised Classification dialog, set the parametric rule to maximum likelihood. Check the Use Probabilities checkbox. Select Classify Zeros if there are background zero values in your data. Click OK in the Supervised Classification dialog to classify the image. When the process is 100% complete, click OK in the Process List dialog. Add 2 more 2D views and load the classified image and the distance raster in each display respectively. Spatially link and sync the 3 views. Adjust the views so that they can be viewed side by side using the vertical layout. Equalize scales and fit the images to view so that the results can be easily interpreted. Note that the classified image has the same colors as specified when collecting the signatures. Also note that brighter pixels in the distance image corresponds to the most likely incorrectly classified pixels, since their Euclidean or Mahalanobis distance from the pixel to the signature mean is relatively large. Zoom into the areas with brighter distance values to view them closely. How does this compare to the results of the contingency matrix? In our next video, we will go through the steps of the Evaluate classification phase in Supervised Classification. Remember to subscribe to the channel and hit on the bell icon to get automatic notifications every time we upload a new video to our channel or to this series.